Ryan, who presented earlier today. And I work with Lynn in the Education and Public Outreach group. So Lynn gave me some comments to share with you all about Claire's work with her. Claire Shudde, sorry, first started working with Professor Kaminsky when she was in high school. So she was 16 years old, and Lynn was very happy to work with her then and was very happy to work with her now. Her path took her to junior college, and then she transferred to Sonoma State University, where she now majored in physics. She again worked with Professor Kaminsky, and one of the things I wanted to mention about Claire's work is in science education, one of the most important things to do when you're developing an activity is to develop that activity with the people, with some of the folks who represent the demographic that you want to use that activity. And so Claire's going to talk a bit about the work she did on an activity for teens to engage them in authentic participation about astronomical images and using remote telescopes.
Hi, so I'm going to be talking about a tutorial that I wrote to encourage students to pursue their interests that they have in science. So the aim of my project is that I want to develop an interest in science, technology, engineering, and math, or the STEM field, through astronomy, because everybody loves space. I particularly want to encourage underrepresented students to go into the sciences, because most science fields are not very diverse, and physics is among the least diverse. I also want to give the students an opportunity to have the opportunity to conduct authentic research and scientific work. So this graph is from the US Census Bureau. It shows the race representations of the total American workforce versus the overall STEM workforce. And ideally, the percentages would be the same in both the total American workforce and the STEM workforce. But as you can see, that's not really the case. So there are two groups that are actually overrepresented in STEM, which means that the percentage is higher for them in STEM than it is in the total American workforce. And those two groups are white and Asian. The other groups that are shown on this graph, which are Black, Native American, Pacific Islander, and Hispanic, are all underrepresented in STEM. This graph is also from the US Census Bureau, and it shows the gender distribution in STEM. So the top two graphs up here are the total American workforce, with men being represented in green and women being represented in yellow. As you can see, they are pretty much almost equal in the total American workforce. The middle graphs here show the number of people who receive a STEM degree. So men receive 61% of STEM degrees in America. Finally, here there is the numbers of people in the STEM workforce in America. So only 24% of the people working in STEM in America are female. For the tutorial that I wrote, I had students create false color images. So every image that we get from a telescope starts out in black and white. And then the scientists can add color to it. And adding color makes it a lot easier to see what's going on, so they can look at an image for a few seconds and get a general idea of what's going on without having to look at it really closely. Color also helps us pick out the details in the images. So one of the common ways to color false color images is to take at least 3 images of the same object and take them in different wavelengths. So this diagram here is from Hubble site, which is a good resource. And they took images of the pillars of creation in the Eagle Nebula. So each picture up at the top here is taken of a slightly different wavelength. So they all show slightly different things. So it's kind of hard to see, but you can see like in this one, the middle color is a bit darker than in this one, which means that they're taking pictures of different kinds of light. So in here, they have 3 images. One of them is taken from wavelengths that correspond to green visible light. One of them is taken from wavelengths that correspond to orange light, and the third is taken from wavelengths that correspond to red light. So the convention when you're coloring images by wavelength is to make the one that has the shortest wavelengths in it blue, which would be the one that was taken from the green wavelength. Then you make the one that shows the longest wavelengths red. And in this case, this one was actually taken from the red wavelengths. Then the one that's in the middle, if there's 3 of them, you color that one green. And as you can see, the colors that you give the images does not necessarily have to line up to the wavelengths and colors that the images show. Finally, these images are all combined into this color image. And you can see that it's a lot easier to pick out details and see what's going on than in these black and white images up here, even though this is bigger. So some common ways to assign color in images are by wavelength, as with this picture, by intensity of light in the image, and often when false color images are taken of, say, Earth or another planet, scientists may color it by elevation, so you can see the different elevation of the surface of the planet. There are also different ways to scale the colors in images. So this is just a different way to represent the colors and see it easier. The 2 more popular ones are logarithmic color scaling and linear color scaling. So logarithmic lets us see the colors, details in the darker parts of the image and the lighter parts of the image at the same time. Linear color scaling tends to make the image look washed out because the parts of the image that have a higher intensity of light overwhelm the darker parts of the image. So these 2 images here are of the same thing. They're both of the Andromeda Galaxy. And they're both made using the same images. The only difference between these 2 are the color scaling. So the top one here was made with logarithmic color scaling, so you can see the detail a lot better. The bottom one here was made with linear color scaling, and as you can see, it's hard to make out the galaxy. So as I said, I had students create false color images in my tutorial. They used images of the Andromeda Galaxy, and the images were available for download and for educational use on the European Space Agency website. And this image here is actually the one that I made of the images, with the images that I gave the students of the Andromeda Galaxy. They use an online program called JS9, which is an online astronomical imaging processor. And it's available all in the browser, so they don't have to download anything or worry about installing it and getting the program running correctly on their computers. In the tutorial, they use resources from Hubble sites, such as the diagram of the Eagle Nebula from a couple slides ago. And then the tutorial is available through the Global Telescope Network, so it's on their website for anyone to see and to use. And the Global Telescope Network is part of what we're working on over in the education and public outreach group here on campus. And I've been working on this program for a couple years now, and I've been working specifically on updating the website for about a year. So I tested my tutorial with some teenagers, since they're the group that I wanted to aim the tutorial at. I went to Pioneer High School and had a focus group with 4 students. There were 2 boys and 2 girls. And what I did was I walked them through the more lecture part. I gave them a miniature lecture on what false color images are and how they work. And because we didn't have enough time for them to sit there and read the whole thing by themselves. And then after I explained false color images to them, I let them loose with the images of the Andromeda Galaxy and JS9 and let them just create a pretty picture so they could change the settings however they wanted and just make something that looked cool, even if it wasn't really scientifically meaningful. I wanted to give them some more freedom and to hopefully have some more fun with it than they get in a lot of lab exercises. So hopefully it would be more engaging to them. And they were very excited about it, which was really cool to see because that's what I wanted. And they all seemed really interested in it and they had a lot of fun. So after they went through and made their own images, I had a discussion with them and asked them what they liked and what they didn't like and what worked and what didn't work. So they really liked that they got to do a hands-on activity and got to just have fun with it and do what they wanted. They also liked that I didn't really give them the answer, so I didn't really tell them what was going to happen when they colored their images of the Andromeda Galaxy and combined them. I just let them see it for themselves. The one big thing that they said could use improvement was an explanation of the different color scales because I didn't really have that in the version that they saw. So then I took their feedback and integrated it into the tutorial and to hopefully make it better and more interesting for students and more helpful. So finally, this project got a lot of help from Brian Mendez, who wrote a lesson plan outline that part of which I based this tutorial off of. Also, Kurt Kruger, who works at Pioneer High, and he helped set up the focus group there. Finally, as I said, this tutorial is part of the Global Telescope Network, which is partially funded by NASA, Caltech, the Jet Propulsion Laboratory, the Smithsonian Astrophysical Observatory, and of course, Sonoma State University. Thank you.
Questions for us, Vika?
It seems like this could be the basis of, continuing science content, right? Once you get into, wavelength dependent information, there's more things for them to come to understand about the universe. Were you thinking of this as fitting in with like a longer curriculum where they might do this with different astronomical objects?
Yeah, so part of this is that with the GTN, the Global Telescope Network, we're trying to create different lessons and not necessarily a whole class worth of information, but just something that maybe an after-school program could use, or if somebody's really interested, they could try it on their own. So I was thinking that this would fit in with that, where they can learn about that and try different types of astronomy.